Let's talk about the electron, not just as some tiny particle from a physics textbook, but as the invisible architect of, well, everything. It's the fundamental artist that paints the stars in the sky and sculpts the very thoughts inside your head.
So let's just jump right in with a pretty wild thought. What if the you that's sitting there, feeling all solid and real, isn't? What if you are, in a very real, very physical sense, mostly empty space, a ghost defined not by substance, but by an invisible, subatomic dance?
Because believe it or not, that's exactly what quantum physics tells us. So for this first part, we're going to tear down this illusion of solidity and show you the shockingly empty and strange reality hiding just beneath the surface.
Okay, so back in 1897, when J.J. Thomson discovered the electron, this number was a huge deal. The electron's mass. It proved it was a real physical thing. But here's the catch. Judging the electron by its mass is like judging a supercomputer by its weight. It tells you absolutely nothing about the incredible software that runs the entire universe.
To really wrap your head around this, picture a massive football stadium. Now, if that whole stadium is one atom, the nucleus at the center would be nothing more than a tiny marble sitting on the 50-yard line. And the electrons, they'd be like a few gnats buzzing around way up in the nosebleed seats. That's how empty an atom is, which means that's how empty you are. So, if we're mostly nothing, why do we feel so solid?
Well, here's a fact that might just break your brain a little. You have never, ever actually touched anything in your entire life. Nope. When you press your hand against a table, you're not feeling solid hitting solid. What you're feeling is the invisible force field of your electrons violently repelling the force field of the table's electrons. It's a perfect and powerful illusion of solidity.
And this really gets to the heart of it, doesn't it? Our everyday classical view tells us the world is made of tiny, solid marbles, dense and full. But the quantum truth is just so much weirder. It's a world built from blurry clouds of pure potential, all humming away in a vast, echoing emptiness.
So, how is this empty stage even governed? What are the rules? Well, it all comes down to the two fundamental properties of the electron's dance, its spin and its charge.
First up is spin. And I have to be really clear about this. It has nothing to do with a tiny ball actually spinning. It's a built-in, fundamental quantum property. Think of it like a tiny internal compass needle that makes every electron act like a microscopic magnet. And this little magnet changes everything. See, that internal compass leads to one of the most important rules in all of physics, the Pauli Exclusion Principle. The easiest way to think of it is as the universe's ultimate no-roommate rule. It says that no two electrons can ever be in the exact same state at the same time. This simple rule is the only thing that prevents atoms from collapsing in on themselves. It forces electrons into different energy shells, and that structure is the reason we have chemistry and the entire periodic table of elements.
The second rule of this quantum waltz is charge. The electron's negative charge is the cosmic glue holding atoms together. It's the relentless attraction to the positive nucleus that drives all of chemistry and all of electricity. It's powering the neurons firing in your brain and the very screen you're looking at right now.
And just how strong is this force? Get this, the electromagnetic force holding an atom together is 10 to the power of 36 times stronger than gravity. That's a 1 with 36 zeros after it. It's an almost unbelievably powerful bond, the true invisible force that's shaping our entire world.
Okay, so we've established that matter is basically a force field illusion governed by some very strange rules. But now we're going off the deep end. We're going to look at the electron's dual nature, a glitch in reality so profound it baffled even Albert Einstein.
So here's the setup for the most famous and frankly, most mind-blowing experiment in all of quantum mechanics. You take a device that can fire a single electron at a time. You aim it at a barrier that has two tiny parallel slits in it, and behind that barrier, you put a detector screen that lights up wherever an electron hits. Simple, right?
I mean, if you're firing tiny little bullets, one by one, you'd expect to see two clean lines on the detector, right? One line for the electrons that went through the left slit, one for the electrons that went through the right. That's just common sense. The problem is, the quantum world couldn't care less about our common sense.
Because this is what they actually saw, an interference pattern, the kind you only get when waves, like ripples in a pond, overlap and interfere with each other. There's only one possible way for this to happen. Each individual electron passed through both slits at the exact same time. As a wave of possibility,
interfered with itself, and then landed on the screen as a single particle.
So you have to just throw away that mental image of a tiny planet orbiting a nucleus. It's not right. A much, much better metaphor is the blur of a hummingbird's wings. You can't pinpoint the wing at any one spot. It exists everywhere in that blur at once. That's the electron, a probability cloud that only snaps into a single, definite location the moment we look at it.
So, if the fundamental ingredient of our universe is this bizarre wave of pure potential, how on earth does it build the solid, predictable world we see around us? Well, let's take a look at the blueprint.
You see, the way those electron probability clouds, those shells, fill up determines an element's entire personality. Take sodium. It's got one lonely exposed electron in its outermost shell, which makes it desperate to give it away. It's highly reactive. Neon, on the other hand, has a completely full outer shell. It's perfectly content, noble, and doesn't want to react with anything.
And these different elemental personalities are what drive all of chemistry. When we talk about chemical bonds, we're really just talking about the invisible threads of reality. It's just electrons being shared or exchanged, atoms holding hands to create molecules. The water you drink, the very DNA that makes you, it's all just held together by this elegant quantum dance.
And this brings us to our final and I think most profound realization. All these abstract rules and spooky behaviors aren't just happening in some distant star or a physicist's lab. They're happening inside of you. Right now, you are quantum. Just consider the idea of quantum entanglement. You can link two electrons in such a way that they become a single system. They're like a pair of magic coins. If you measure one and find out its spin is up, you know instantly that its partner, even if it's on the other side of the universe, will have a spin that is down. This phenomenon was so bizarre, so completely against how we think the universe should work, that it deeply disturbed Albert Einstein. He famously, and kind of dismissively, called it spooky action at a distance. It suggests that on the deepest level, the universe isn't a collection of separate things, but a single, deeply interconnected web.
And here is where it all comes together. Every color you perceive, every thought that flickers through your mind, every single feeling you have is the direct result of electrons jumping between those energy levels in your brain, absorbing and spitting out little packets of light. Your entire conscious experience is, in a very real sense, a continuous, intricate quantum light show.
So the next time you look in the mirror, remember this. You are not a solid, static object made of tiny, boring particles. You are a manifestation of these incredible quantum laws. You're not just made of electrons. You are the beautiful, complex, and constant result of their invisible quantum dance.